OMG! It's observed molecular genetics. DNA forensic analysis, like DNA fingerprinting, is one key use of the PCR technique. Now it's time to create the master mix, which is a combination of solutions that contain all of the necessary ingredients for PCR. Right now I'm adding a buffer to a clean tube. We keep the tubes on ice so that none of the ingredients degrade while we're setting up the PCR reactions. Here I'm using a P1000, a pipette that can measure up to 1,000 microliters, to dispense a specific amount of water that will be used to dilute the buffer that's in the master mix tube at this point. So there's the water. The pipette measures a fixed number of microliters. And now I gently add that liquid to the buffer. And the buffer contains detergent, so as I agitate and mix the solution, some bubbles form. I'm mixing the solution thoroughly, and then I'm finished with that addition of liquid. Time to add the deoxynucleotide triphosphates, or dNTPs, to the master mix. I use a micropipette to remove 10 microliters of liquid. There it is. And then I add that to the tube where I'm combining all of the PCR reagents. Now it's time to add the DNA polymerase. We keep this enzyme in a benchtop cooler to make sure that the protein stays cold at all times, because proteins degrade over time, especially when they're warm. So here I'm taking out a couple of microliters of liquid for my entire set of PCR reactions. And then back into the freezer, the enzyme box goes. Now that I'm done adding all of the PCR components to each tube, I briefly centrifuge the tubes to collect all of the liquid at the bottom of each tube. And I verify to make sure that there is the correct amount of liquid in each tube. Now I need to completely seal all of these tubes. This is important because PCR uses heat to denature the DNA, and that amount of heat would evaporate all of that tiny amount, 10 microliters of liquid that's in each of these tubes. So I make sure that they're completely sealed. Now that the tubes are sealed, I move them into our PCR machine, which is an incubator that controls the temperature of the tubes to make sure that they are kept at temperatures appropriate for DNA synthesis. So I add all of those tubes of reactions to the aluminum block in the PCR machine. After closing the lid, I select a specific set of temperatures and reaction conditions. Finally, I run this program after confirming the volume of each of the reactions. Here I see how long the process is going to take, and the temperatures, and the times, and the number of cycles before my experiment is complete. Thanks for watching, and please be sure to be in touch if you have any questions.